Good day, everyone. Thank you very much for this opportunity to present to you our live stream. And today's lesson will be looking at the 2018 Feb March um, question paper, and I'll be looking at question 9. And I will present this lesson as I would do for my learners. And please feel free to in the chat function, just add any questions. And the lady that will assist me is a teacher from Paul. She's teaching at Santa Clara, and she will be the moderator, so she will check the chat for us. And in that, we also would like to demonstrate the power of collaboration, so that we are able to benefit from all these possibilities that goes along with this. But nevertheless, I'm going to start, and I'm going to just start with the question. So given to us here is sketch below represents the curve of the f of x cubed plus bx squared plus cx plus d, and the solutions of the equation the f of x is equal to 0 are -2, 1, and 4. So these values are important values that we need to understand before we attempt to answer the question. And given to us is the f of x equals to 0, which means that this also relates to y equals 0. And when we make our equation y equal to 0, this is when we want to determine our x intercepts. Okay, so what these values represent all my x values. So this will be x equal to -2, x equal to 1, and x equals to 4. So now I'm dealing with equations. So if I work backwards, this came from the following: x plus 2 equal to 0, x minus 1 equal to 0, and x minus 4 equals to 0. So now I've basically worked from these given values to what my factors are. So if I'm going to work backwards, basically this came from x plus 2 times x minus 1 times x minus 4. Robin, do we have any questions at this point in time? None. So this will assist the learner, will assist you now to understand what your point of departure is. Remember, this is not yet answering the question. This is just taking the information given to you in the question. And the information given to you here is the f of x equal to 0 are -2, 1, and 4. And that is our point of departure. This will serve as the most important aspect of answering this question, and that is your prior knowledge. So keep in mind that when you attempt or answer any questions in the exams and your prior knowledge is non-existent, you will have a very great struggle to answer the question. So make sure that when you enter the exam room, that your prior knowledge is of such a nature that you are able to address the questions that will be asked in the paper. Okay, so let me just get my colors out here. So the next thing for us now to do is to answer the question. So 9.1 is calculate the values of B, C, and D. Now the first question you ask yourself before answering the question is, what prior knowledge do you need to answer these questions? You need to be able to identify where to find B, C, and D. And that is also given to us in the standard form equation. And the standard form equation is f of x equals x cubed plus bx squared plus cx plus d. And within this, I can see b, I can see c, and I can also see d. Right? So basically, What we now need to do is to work from what we have here and find the solutions to A, B, C, D, and D. So basically, what needs to be done here is, again, you ask yourself what prior knowledge is required here. We will find the product to get us to our equation. Good. So the next thing for us to do is to take what we have here. Okay, I'm just muting my notifications because I assume that it is picking up on mine. There we go. So now we need to take these values and we need to find the product of this. So I'm going to rewrite this: x plus 2, x minus 1, and x minus 4. And when I simplify this, I will then have x squared plus x minus 2 times x minus 4. And when I simplify this part, I then have x to the power of 3 minus 3x squared minus 6x plus 8. Now let's go back to the question. They wanted us to find A, B, C, and D. Okay, and we have identified that that is B there, that is C there, and that is D there. Okay. So in my solution, I look for the position of B, I look for the position of C, and I look for the position of D. Okay, B is the coefficient of x squared and negative 3. So B is equal to negative 3. Okay, so that is done. C is the coefficient of x, negative 6 is the coefficient of x. So C is equal to negative 6. And then D is equal to 8. Therefore, D is equal to 8. And this is how you find the solution to 9.1. Do we have any questions? Robin, are there any questions there? Thank you very much for that, Mr. Walker. I see your message on something I haven't decided here as well. Okay, so Robin, thank you very much for introducing yourself. And we will move on to question 9.2. Are there any questions at this point in time? Any questions about the quest about 9.1? Okay, none at this time, so that's good. So I will then move on to the next question, and the next question is 9.2. So the next question asks of us to calculate the x coordinate of B, the maximum turning point of F. So if we look at B to calculate x coordinate, so when I calculate x coordinates, I need to first ask myself, now again the same questions, what is my prior knowledge? You need to depart with every question with what is your prior knowledge. If you don't have that prior knowledge and you need to recall that prior knowledge, you move on to the next question. But be careful with functions because those questions are follow-up questions in most cases. Okay, so let's have a look at 9.2. So 9.2, they want us to determine the x coordinate of B, the maximum turning point of F. So let's have a look at how we do that. So 9.2, we're looking at the function, which is now known to us because we have determined the function in the previous question. So the f of x is equal to x to the power of 3 minus 3x squared minus 6x plus 8. Okay, and in order to find the x coordinates, we need to look at the first derivative. So the first derivative, we make it equal to 0. This will be a mark, so you have to do that. Okay, and the first derivative of that, if I apply the power rule, will then be, remember now the f of x is 0, so it's going to be 0 equals 3x squared minus 6x minus 6. Okay, so now that's my first derivative, and from this I will now simplify. And to save time in the exams, don't break your head to try to factorize something. Don't do that, because that's going to waste time. Use the quadratic formula because that will always give you an answer. Whether it's a decimal answer or whether it's a natural number, you will always get an answer with your quadratic formula. So I can simplify by dividing with 3. So I'm going to have x squared minus 2x minus 2 is equal to 0. Okay, So now I take my A, I identify my A, B, and my C values because I'm going to use my quadratic formula. So A is 1, B is negative 2, and C is negative 2. Okay. So now I bring in my quadratic formula. My quadratic formula is x is equal to minus b plus minus b squared minus 4ac divided by 2a. Mr. Isetu, you asked me to explain the power rule. So with the power rule, what I'll do is, if a learner, excuse me, wants me to explain them the power rule, and I only have 15 minutes now, but if you can allocate me more time, then I will do that. But for the sake of the learners, I already have pre-recorded lessons, and those pre-recorded lessons I will then add at the end for them, so they will do their activities. They first need to go back to the power rule to refresh their memories, so that they use that as their prior knowledge when they approach the question. So I hope that answers your question, Mr. Stofile. Just let me know in the chat, and then I will see if I can get back to it, and I will explain the power rule as well. Okay. So the next thing for me to do is I now need to go and substitute my values into my equation, and I use it because I've allocated my values already on my left hand side. It's very easy to put your things out nice and orderly, so you don't have to think about it. It's in front of you. So now when I substitute, x is equal to minus b plus minus. So b at this point in time, we should already replace our values, but I'm just going to rewrite it now because I've already done that. So you don't rewrite it. This is my mistake that I've made, but it doesn't make the calculation wrong. So x is equal to minus, now my b value is minus 2. Okay, and I put minus 2 wherever I see b. My a value is 1, and my c value is minus 2. Okay, and my a value is 1. Okay, so all I now do is just to simplify, making sure that I also multiply with my signs and getting my signs right, because my signs, if I get my signs wrong, then obviously my answer will be incorrect. Okay, so when I simplify, x is then equal to 2 plus minus 4 plus 8, and that divides by 2. So x is therefore 2 plus minus 12. X is then therefore minus 0.73. You will also get the positive answer, but the correct one here would be this, based on the question. Let's go back to the question. Okay, so they want us to find the maximum turning point of f. Okay, so the next thing, any questions at this point in time? Mr. Walker, previous lessons before? Thank you very much for that suggestion and comment that you made there, Mr. Walker. Okay, so we are looking at 9.3. So for 9.3, they want us to determine the equation for the tangent to the graph of f at x equals to 1. Okay, and basically what at negative 1, x is negative 1. So basically what we do there is a basic substitution. Okay, but keep in mind that the tangent, okay, the tangent is a straight line. Okay, that's what you need to understand. And determine for the tangent to the graph of f at x equal negative 1. So for the f of x, okay, we first substitute that into the position of x, which is minus 1. Okay, and what I do is I then substitute that negative 1 into all my x positions. Okay, so negative 1 to the power of 3, 3 times negative 1 to the power of 2, minus 6 times negative 1 plus 8. And when I simplify that correctly, that gives me 10. Okay, so I'm just now setting up my values to find my solution. And then my first derivative, that we've calculated from the previous calculation was 3x to the power of 2 minus 6x minus 6. And I take the same value and substitute that into my first derivative, which is now 3 times minus 1 to the power of 2 minus 6 times minus 1 minus 6, and this gives me 3. So now I have those values. Okay, so at this point in time, I'm at 10:15, so my time has expired. But what I'll do now is I will just go through the slide quickly for the video to show how the video would end. So basically, what I would have is then my calculations on the last question, and then the next part
Today, in
would
today's
be
lesson, we'll be
to show
looking at a
learners.
cubic
This is
function,
now a
more specifically
pre-recorded
sketching a
video
cubic
where
function.
learners can now
So
look
let's
at how to
that I've mentioned
construct
the significance of them.
the
So when a
concept
is
of a cubic
greater than
function
0,
and
this
also what
is the
these
shape of our graph.
variables mean.
When a is
So
less
this
than
was a
0,
pre-recorded
this
lesson
is the shape of our graph.
made
So
a
we can
long time
also
ago,
say
and
when
learners will then be able to view
x squared,
go
we need
step
to
by
make
step through all
the
of these.
derivative.
And
Now
we
that's
also
the
made
first
quite a
derivative
calculated
equal to 0, and when we solve, add it
and
to it. And then I read
video
4 over
lessons,
3
so small
and
instructions
negative
that learners can use for
224
system.
over
And then my
20.
final scene would obviously be my details for parents and teachers and learners to get in contact when they either need any form of ICT integration or any assistance with lessons. And that is my part from my side. Mr. Stofile and the audience, thank you very much for this time and opportunity. I really appreciate it. And if you need anything further, please let me know. And hopefully, I will be able to post or be um, colleagues. I will continue on this link. So please let me know if you are able to see or view me. I will be continuing on this link and then just show you different ways in which we can use streaming platform to enable teaching and learning to take place as a live format. Colleagues, I will continue on this link. So please let me know if so. Basically, the options that we have for this is, and as you've seen with my video, I was able to have a video of myself in the first scene where I had set up my my question. So all my questions I will use screenshots and I will paste those questions as images into my broadcasting software, and I will put myself next to it, so I'm able to speak to the learners, and they can also have that focus because not just hearing your voice takes away that human factor in the sense that you can't see you. And the next scene that I had was me being able to use the document viewer to set up my sheets of paper, and if whatever preparation that I have, and these will be my follow-up lessons I'm going to do with my learners. So I have my question diagrams printed out on white paper. So I will be working through all of these with my learners, and my learners will be able to then see and relate to the questions that I'm busy with, and all my recording lessons. So I will use this for exam preparation for my grade 12 learners. So everything has been printed out so that I have those, because it takes time to redraw them, and you don't necessarily get an accurate drawing when you do that. My next scene that I have set up was
Today, in today's lesson, we'll be
made,
looking at a cubic
and the
function, more
pre-recorded
specifically
video
sketching a
allows
cubic
you
function.
to
So let's first
play
understand
the
what a
video for
general
learners,
form should
and
look like.
I've
And this is the
digitized
sequence
this
for your
lesson.
general form, ax
I'm
cubed
not
plus
using
bx squared
document
plus
viewing this
cx
lesson.
plus
I've
d.
digitized
Cube,
this
an
one, so there's
indication that
quite intense
y
speech for
is our
itself,
basic
but
shape of our
if I
graph,
have
and
narrated
this is
over this,
determined by a.
learners
Hence
can
the
hear my
fact that
voice,
negative value
and I
gradient
can
and
also
positive
speak
gradient.
over this lesson.
So from a negative
So I'm
gradient,
now able
your
to show
graph
learners how the
moves, and when
gradient
it
of
gets to
the
this
graph
point here,
positive,
that is your local minimum
and I
negative.
can move
The
to
next
this lesson,
important
I can also
aspects
show
of
them
your graph is
what
you need to
minimum
understand
concave
what your
up
local
means and what
minimum is,
maximum
which
concave
refers to
down
concave
means,
up, and
and
also your
also
local
demonstrate the point of inflection.
maximum, which is concave
So
down.
this is how
Now,
I can now narrate
there's a very
over an
important
existing
aspect of
video.
this
I
function
don't
as well,
use the
and
sound
that
of the existing
is the
video,
point of
but what I'm
inflection.
using,
So your point of inflection is a
my
point on a
narration
curve
over
at
that
which the
video, so
sign
learners
of the
are able to
curvature or the
see
concavity
the inflection
changes,
as well.
and you
So
also need to know the examples which is
continuing
positive.
to this one,
So
this was
here we can only take
one of
0
the
and then
lessons that
x is
I've
equal
made.
to x is 0 and then x is
So
6 at this point.
and
So there
you can
you
literally
need to make
put anything
the derivative
into
you need to make.
live stream. So
Now the next
you
thing to
can
do is
set
to
up your
rewrite
lesson
this in
plans,
standard form.
well-structured
That's
lesson
very
plans. You
important
can
because
connect with external
remember we are
sources.
used to
You
working
can
with
put in
things in
image
standard
files.
form.
You can put in different scenes. You can navigate through scenes.
Today in today's lesson we'll
The
be
transition from scene to scene is quite smooth. So there's no obstruction between scene to scene. However, you need to be aware of your scenes
today
when you
in
do
today's
your-
lesson
when you do your lesson plan, because one of the errors that I've experienced now was, well, not error, it was me talking about the lesson, but I didn't show me doing the calculation of the lesson. Okay, so that was one of the things that I've experienced. And the nice thing about the live chat is it enables learners to be able to communicate with you. And the nice thing about the moderator is that that person will be able to will be able to chat and will be able to give feedback to the participants within your class. And very important is that with your moderator, you absolutely need to know the lesson. So you have to discuss the lesson so that the moderator knows exactly where you are and what some of the questions are that may come up, because you can preempt those things. And so the moderator needs to be a good thing. So, and then again, Mr. Walker has mentioned about 150 kilometers. Thank you for those comments, Mr. Walker. And you are able to work with anyone, anywhere. So distance is not an issue. The only problem is that you need to have data. So I'm using a pocket Wi-Fi because this is a more reliable one for me now. I have Wi-Fi at home, but I don't think that's going to be reliable. So I'm using my own data for this, able to live stream without buffering. So data is king when it comes to these recordings, and it's all the tools are free. So your the YouTube channels are free. The OBS software I'm using, that's also free. It's OBS, Open Broadcasting Software. It allows and enables you to create your lessons, and then it links with YouTube, and everything that you plan and display on OBS will then be played through YouTube as well. I would like to take this time and just to ask if there's any questions. Please feel free to post any questions, or just make any comments or suggestions or things that you may be concerned about, and then from there we can maybe have a discussion about those type of questions that you may have. So I will just give some a few moments for everyone, maybe just to ask a question or make a comment. Then maybe I can address it from my side as well. Okay, there are no questions there. So the next presenter is going to come up and we just need to give her about a few minutes to set up and get everything ready, and then hopefully we will have her live as well, because I don't see any questions. Okay, Robin, Ronald, the last display. Okay, so Robin has set the last
Today,
video
in
and
today's
audio.
lesson, we'll be looking at a cubic
Okay.
function.
Robin, I'm
Today,
gonna play
in
this video
today's
again.
lesson,
You
we'll
hear
be
the
looking
audio?
at a cubic function, more specifically sketching a cubic function. So let's first understand what a general form should look like. And this is the sequence for your general form: ax cubed plus bx squared plus cx plus d. Cube, an indication that we are working with a cubic function. And we are also going to look at the significance of a and what a represents. So the first thing we would like to identify is our basic shape of our graph, and this is determined by a, hence the fact that I've mentioned the significance of a. So when a is greater than 0, this is the shape of our graph. When a is less than 0, this is the shape of our graph. So we can also say when a is positive, this is the shape of the graph, and when a is negative, this is the shape of the graph, because all positive values are greater than 0 and all negative values are less than 0. Let's have a look at the following.
Okay, so basically for that, I'm gonna have to go and change go to my settings, and obviously I need to take off the sound and to mute that. And that is something that I can do when I do my lessons with my learners, so that shouldn't be a problem there. Okay. And that, colleagues, I'm done with that part there. And once again, thank you very much for the opportunity, and thank you very much for your time. And Mr. Sophile, if you can hear me, um, just let me know what else you need, and I will make sure that I'm able to set up and engage with the audience again. Thank you very much.